Hi, good morning. In the previous video, we have discussion over ideal gas and the molecular kinetic theory and molecular speed. In the kinetic theory of gases, we studied a few postulates. There are 7 important postulates are there. All the 7 postulates are very important. Okay. After that, scientists the curiosity to identify to solve the variation of real gas with the ideal gas. Why real gas not become an ideal, or in which condition it is possible, and what is the main reason of behavior of real gas not like ideal. Okay, to know all these things, after the study of the real gas, the scientists saw one thing, that two postulates of kinetic theory is not holds good, or it's wrong, completely wrong for a real gas system. Okay, ಏನಾಗಿದೆ ಇಲ್ಲಿ ರಿಯಲ್ ಗ್ಯಾಸ್ ಮತ್ತು ಐಡಿಯಲ್ ಗ್ಯಾಸ್ ಬಿಹೇವಿಯರ್ ಅಬ್ಸರ್ವ್ ಮಾಡಿದರೆ ರಿಯಲ್ ಗ್ಯಾಸ್ ನಾಟ್ ಬಿಹೇವ್ಸ್ ಲೈಕ್ ಎನ್ ಐಡಿಯಲ್. ವಾಟ್ ಇಸ್ ದ ರೀಸನ್ ಆಫ್ ದ್ಯಾಟ್? ಸೊ ಅದರ ರೀಸನನ್ನು ಐಡೆಂಟಿಫೈ ಮಾಡಲಿಕ್ಕೆ ಹೋದಾಗ ಎರಡು ಪಾಸ್ಟುಲೇಟ್ಸ್, ಕೈನೆಟಿಕ್ ಥಿಯರಿಯ ಪಾಸ್ಟುಲೇಟ್ಸ್ ರಾಂಗ್ ಆರ್ ನಾಟ್ ಹೋಲ್ಡ್ಸ್ ಗುಡ್. ಸೊ ಅದು ರಿಯಲ್ ಗ್ಯಾಸಿಗೆ ಒಬೆ ಆಗೋದಿಲ್ಲ, ರಿಯಲ್ ಗ್ಯಾಸಲ್ಲಿ ಒಬೆ ಆಗೋದಿಲ್ಲ. ಸೊ ಅದನ್ನು ಐಡೆಂಟಿಫೈ ಮಾಡಿ. ಸೊ ಯಾವ್ಯಾವುದು ರಾಂಗ್ ಆಗಿದೆ, ಯಾವ ಅಸಂಪ್ಷನ್ ಆರ್ ಯಾವ ಪಾಸ್ಟುಲೇಟ್ಸ್ ಹೋಲ್ಡ್ಸ್ ಆಗೋದಿಲ್ಲ. The one postulate is there is no force of attraction. There is no force of attraction between the gaseous molecule. No, it is not true. This postulate is not true. Okay, yes, there is some force. What type of force? London force. It may be a London force, correct? So there may be a possibility of presence of a London force between the gaseous molecule. Therefore, one postulate in the kinetic theory is not completely holds good for a real gas. Yes, in ideal case it is true. Next, another one is the volume of a gas molecule. Volume of a one gaseous molecule is completely negligible compared to the volume of the total volume of the gaseous system. It is also not completely true for ideal real gas condition, because if we consider this small gaseous system, then there is a possibility of comparison between the volume of one gas molecule with the gaseous system. Therefore, these two postulates is not completely holds for the real gas system. Therefore, we observe the deviation of real gas with the ideal gas. Okay, let us discuss about the deviation of real gas with ideal gas, or it is also known as deviation of real gas with ideal behavior. How it deviates with the ideal behavior. Okay, this deviation is represented using a graph. When we plot a graph of pressure versus volume, this graph is known as PV graph. This graph is studied under Boyle's law, correct? It is studied under Boyle's law. Suppose we plot a graph of the constant PV. PV is constant in that cases, correct? So PV versus V, or pressure versus volume also in all these cases. Okay, suppose we plot a graph of PV versus volume, then ideal gas gives constant or gives constant curve. So this one is parallel to the x-axis. Is parallel to x-axis. So what is the reason of parallel to x-axis? So this is the PV line. Okay, PV is equal to constant in case of ideal gas. What is ideal gas equation? PV is equal to nRT for a given temperature. For a given temperature, what happened? In a given temperature, amount of a substance is constant and R is a gas constant. Whole thing in the product side, whole thing or right side, whole thing is constant for a given temperature. That means PV remains constant. Okay, whenever we change the volume or pressure, there is no change in the product of pressure and volume. So therefore it gives a constant. After the observation of this one, there is a new factor is introduced. That factor is called compressibility factor. Okay, very important. Another thing is compressibility factor. Compressibility factor. It is represented with a symbol Z. Okay, ಏನಾಗಿದೆ ಇಲ್ಲಿ variation of ideal gas ಅನ್ನು ಅಬ್ಸರ್ವ್ ಮಾಡಿದಾಗ there is no variation with volume or pressure. Ideal gas pressure or volume ಜೊತೆಗೆ ಏನು ವೇರಿಯೇಷನ್ ಅನ್ನು ಕೊಟ್ಟಿಲ್ಲ. So because of that it is remains constant. ಅದು ಕಾನ್ಸ್ಟೆಂಟ್ ಆಗಿದೆ. So constant curve with parallel to volume or pressure axis. ಸೊ ಅದನ್ನು ಅಬ್ಸರ್ವ್ ಮಾಡಿದ ಮೇಲೆ ಒಂದು ನ್ಯೂ ಫ್ಯಾಕ್ಟರ್ ಅನ್ನು ಇಂಟ್ರೊಡ್ಯೂಸ್ ಮಾಡಿದ್ವಿ. ಇಟ್ ಈಸ್ ಕಾಲ್ಡ್ ಕಂಪ್ರೆಸಿಬಿಲಿಟಿ ಫ್ಯಾಕ್ಟರ್. ಓಕೆ, ರಿಯಲ್ ಗ್ಯಾಸ್ ಗಿವ್ಸ್ ಡಿವಿಯೇಷನ್, ಐಡಲ್ ಗ್ಯಾಸ್ ಡಸ್ ನಾಟ್ ಗಿವ್ಸ್ ಡಿವಿಯೇಷನ್. ಹೌ ಮಚ್ ಡಿವಿಯೇಷನ್ ಗಿವನ್ ಬೈ ದಿಸ್ ರಿಯಲ್ ಗ್ಯಾಸಸ್? ರಿಯಲ್ ಗ್ಯಾಸ್ ಎಷ್ಟು ಡಿವಿಯೇಷನ್ ಕೊಡ್ತದೆ, ಎಷ್ಟು ಕಂಪ್ರೆಸ್ ಆಗ್ತದೆ ವಿತ್ ಐಡಲ್ ಗ್ಯಾಸ್. ಸೊ ಅದಕ್ಕೆ ನ್ಯೂ ಫ್ಯಾಕ್ಟರ್ ಇಸ್ ಕಾಲ್ಡ್ ಕಂಪ್ರೆಸಿಬಿಲಿಟಿ ಫ್ಯಾಕ್ಟರ್. What is the reason of introducing this factor? Reason is to determine the compressibility of the real gas with ideal gas. How much it compressed, ಎಷ್ಟು ಕಂಪ್ರೆಸ್ ಆಗ್ತದೆ ಆಗೋದಿಲ್ಲ. ಸೊ ಅದನ್ನೆಲ್ಲ ಸ್ಟಡಿನ ಒಂದು ಫ್ಯಾಕ್ಟರ್ ಇಂದ ನಾವು ಮೆಜರ್ ಮಾಡ್ಬೋದು. ದಟ್ ಈಸ್ ನೋನ್ ಆಸ್ ಕಂಪ್ರೆಸಿಬಿಲಿಟಿ ಫ್ಯಾಕ್ಟರ್. ಸೊ ಇಟ್ ಈಸ್ ರಿಪ್ರೆಸೆಂಟೆಡ್ ಯೂಸಿಂಗ್ ಸಿಂಬಲ್ Z. Okay, so now the graph is just changed along y-axis and consider now compressibility factor. Then what is compressibility factor and how to express this compressibility factor? Mathematically, the compressibility factor Z is equal to PV by nRT. Okay, just it is a measurement. Compressibility factor is just a measurement. Okay, so define compressibility factor. There is a possibility of asking the question. So ಅವಾಗ ಏನು ಮಾಡ್ಬೋದು ನೀವು? ಜಸ್ಟ್ ಈಕ್ವೇಷನ್ ಥ್ರೂ ಸ್ಟೇಟ್ಮೆಂಟ್ ಅನ್ನ ಹೊರಡ್ಬೋದು. ಏನು? ಸೊ ಕಂಪ್ರೆಸಿಬಿಲಿಟಿ ಫ್ಯಾಕ್ಟರ್ ಇಸ್ ದ ರೇಷಿಯೋ ಆಫ್ ಪ್ರಾಡಕ್ಟ್ ಆಫ್ ಪ್ರೆಷರ್, ವಾಲ್ಯೂಮ್ ಅಂಡ್ nRT. Okay, so this is a compressibility factor equation. So in this equation, compressibility factor equation Z for a given condition ಅಂತ ಹೇಳಿದಾಗ ಏನಾಯ್ತು? ಟೆಂಪರೇಚರ್ ಕಾನ್ಸ್ಟೆಂಟ್, amount of a substance constant, R constant, whole thing constant. Z is entirely depend upon the or the directly proportional to PV, product of pressure and volume. Compressibility factor is directly proportional to product of volume and pressure at constant temperature. So that ideal gas, in case of ideal gas, it gives a straight line. It gives straight line. Next, what is the behavior of real gas? The real gas shows some deviation. Shows some deviation. Few does not shows any deviation. So these are the different gases. Okay, for example, this one is a nitrogen N2, this one is carbon dioxide. These are shows deviation. And also this one is a hydrogen gas. Suppose you consider it is hydrogen. Yes, it is hydrogen. This one is helium, like that. Okay, hydrogen gas, helium gas, oxygen gas, nitrogen, carbon dioxide, methane. Okay, so methane also shows a negative deviation again, small negative deviation is observed. Okay, so different real gases means ordinary, in ordinary condition, whatever the gases are there and in ordinary condition. So these gases shows such type of deviations. uh, Ideal gas shows a constant curve and other shows deviated curves with the ideal gas. When we compare the real gas, the behavior of the real gas with ideal gas, pure real gases shows negative deviation and few does not shows negative, only positive deviation is observed. Correct? Few shows positive deviation, few shows negative deviation. The negative deviation and positive deviation is completely depend upon, or that one is measured using the compressibility factor. ಯಾವ ಗ್ಯಾಸು ನೆಗೆಟಿವ್ ಡಿವಿಯೇಷನ್ ಅನ್ನು ಕೊಡ್ತದೆ. ನೆಗೆಟಿವ್ ಡಿವಿಯೇಷನ್ ಅಂದ್ರೆ ಏನಾಗಬೇಕು, ಐಡಿಯಲ್ ಗ್ಯಾಸ್ಗಿಂತ ಕೆಳಗಡೆ ಬರಬೇಕು. ಪಾಸಿಟಿವ್ ಡಿವಿಯೇಷನ್ ಅಂದ್ರೆ ಏನು, ಐಡಿಯಲ್ ಗ್ಯಾಸ್ಗಿಂತ ಕೆಳಗಡೆ ಬರೋದಿಲ್ಲ, ಸ್ಟ್ರೇಟ್ ಗ್ರಾಜುವಲ್ ಇನ್ಕ್ರೀಸಿಂಗ್ ಪಾಸಿಟಿವ್ ಸ್ಲೋಪ್ ಅನ್ನ, ಆಲ್ವೇಸ್ ಪಾಸಿಟಿವ್ ಸ್ಲೋಪ್ ಇದೆ, ಇಲ್ಲಿ ನೆಗೆಟಿವ್ ಸ್ಲೋಪ್ ಅನ್ನ ಅಬ್ಸರ್ವ್ ಮಾಡಬಹುದು. ಸೊ ರಿಯಲ್ ಗ್ಯಾಸಸ್ಸು ಫ್ಯೂ ನೆಗೆಟಿವ್ ಸ್ಲೋಪ್ ಕೊಡ್ತದೆ, ಫ್ಯೂ ಪಾಸಿಟಿವ್ ಸ್ಲೋಪ್ ಕೊಡ್ತದೆ. ಆ ಪಾಸಿಟಿವ್ ನೆಗೆಟಿವ್ ಡಿವಿಯೇಷನ್ ಎಷ್ಟಿದೆ ಅದನ್ನು ಮೆಜರ್ ಮಾಡಲಿಕ್ಕೆ ಯೂಸ್ ಮಾಡಿರೋದು ಕಂಪ್ರೆಸಿಬಿಲಿಟಿ ಫ್ಯಾಕ್ಟರ್. ಸೊ ಇನ್ ಕಂಪ್ರೆಸಿಬಿಲಿಟಿ ಫ್ಯಾಕ್ಟರ್, ಓಕೆ, ಇನ್ ಕಂಪ್ರೆಸಿಬಿಲಿಟಿ ಫ್ಯಾಕ್ಟರ್, suppose we consider ideal gas. For an ideal gas, Z is equal to, for an ideal gas ಏನಾಗಿರ್ತದೆ, ideal gas ಅಲ್ಲಿ PV is equal to nRT. When PV is equal to nRT, when equation number 1 shows PV is equal to nRT, mathematical equation, P, when Z is equal to 1, when Z is equal to 1, PV is equal to nRT. It shows PV is equal to nRT. That indicates value of Z. What is the meaning of Z? Z is compressibility factor. Z is 1, or compressibility factor is 1 for ideal gas. Okay, for an ideal gas, Z is equal to 1. Next, for real gas, PV is not equal to nRT. Correct? PV is not equal to nRT. PV is not equal to nRT means, what is the meaning of that? Z may be greater than 1 or Z may be less than 1. Okay, Z may be greater than 1 or Z may be less than 1. So depending upon the value of Z, greater than 1 and less than 1, the more compressibility and less compressibility nature is measured. Okay, ಏನಾಗಿದೆ ನೋಡಿ, ಕಂಪ್ರೆಸಿಬಿಲಿಟಿ ಫ್ಯಾಕ್ಟರ್ Z ನ ವ್ಯಾಲ್ಯೂ ಒಂದಕ್ಕಿಂತ ಜಾಸ್ತಿ ಇದೆ, ಒಂದಕ್ಕಿಂತ ಕಡಿಮೆ ಇದೆ. ಸೊ ಇದ್ರ ಮೇಲಿಂದ ಕಂಪ್ರೆಸಿಬಿಲಿಟಿ ನೇಚರನ್ನು ನಾವು ಅಬ್ಸರ್ವ್ ಮಾಡ್ತೇವೆ. ಮೋರ್ ಕಂಪ್ರೆಸಿಬಲ್, ಲೆಸ್ ಕಂಪ್ರೆಸಿಬಲ್, ಸೊ ಆಲ್ ದ್ಯಾಟ್ ಥಿಂಗ್. ಜಸ್ಟ್ ಇಲ್ಲಿ ನಾವು ಅಬ್ಸರ್ವ್ ಮಾಡಿದ್ರೆ, ದ ಗ್ಯಾಸ್ ವಿಚ್ ಗಿವ್ಸ್ ನೆಗೆಟಿವ್ ಡಿವಿಯೇಷನ್, ಇಲ್ಲಿ ಗ್ಯಾಸ್ ಯಾವುದು ನೆಗೆಟಿವ್ ಡಿವಿಯೇಷನ್ ಅನ್ನು ಕೊಡ್ತದೆ, ಸೊ ಆ ಗ್ಯಾಸಿಗೆ ನಾವೇನು ಹೇಳ್ತೇವೆ, ಲೆಸ್ ಈಸಿಲಿ ಕಂಪ್ರೆಸಿಬಲ್ ಗ್ಯಾಸ್ ಈ ಅಂಡರ್ಗೋ compressible with small amount of pressure and temperature. So temperature ಒಂದು ಆರ್ಡಿನರಿ ಕಂಡೀಷನ್ ಅಲ್ಲಿ ಇದ್ದು ಸ್ವಲ್ಪ ಪ್ರೆಷರ್ ಅನ್ನು ಕೊಟ್ಟಿದ್ರು ಕಂಪ್ರೆಸಿಬಲ್ ಆಗ್ತದೆ, ಈಸಿಲಿ ಕಂಪ್ರೆಸಿಬಲ್. ಅಂಡ್ ಗ್ಯಾಸ್ ವಿಚ್ ಗಿವ್ಸ್ ಪಾಸಿಟಿವ್ deviated gases, so not easily undergo compression. So that means we need more amount of pressure, not only more amount of pressure, we need a smaller temperature. ಸೊ ಆರ್ಡಿನರಿ, ಈಗ ಜನರಲ್ ಆಗಿ ತಗೊಂಡ್ರೆ ನೀವು ಗ್ಯಾಸನ್ನು ಲಿಕ್ವಿಫೈ ಮಾಡಬೇಕಂದ್ರೆ ಏನೇನು ಮಾಡಬೇಕು, ಪ್ರೆಷರನ್ನು ಅಪ್ಲೈ ಮಾಡಬೇಕು, ಜೊತೆಗೆ ಟೆಂಪ್ರೇಚರನ್ನು ಕಡಿಮೆ ಮಾಡಬೇಕು. ಸೊ ವೆನ್ ವಿ ಡಿಕ್ರೀಸ್ ದ ಟೆಂಪ್ರೇಚರ್, ಅಲಾಂಗ್ ವಿತ್ ದ್ಯಾಟ್ ವೆನ್ ವಿ ಅಪ್ಲೈ ದ ಪ್ರೆಷರ್, ದೆನ್ ಗ್ಯಾಸ್ ಗೆಟ್ ಕಂಪ್ರೆಸ್ಡ್. ಕರೆಕ್ಟ್? So in few gases condition, we need more amount of pressure and less amount of temperature. These gas shows positive deviation. Example, hydrogen, helium gases. Alva, hydrogen liquefy ಮಾಡೋದು difficult. Gases molecule far apart each other. There is no force of attraction. In case of hydrogen, force of attraction is less. Polar, non-polar. ಸೊ ಕಂಪ್ಲೀಟ್ ನಾನ್ ಪೋಲಾರ್ ಇರ್ತದೆ. ಸೊ ಅದನ್ನು ಅಟ್ರಾಕ್ಟ್ ಮಾಡ್ಕೊಳ್ಳೋದಿಲ್ಲ ಅವು. ಸೊ ಅದಕ್ಕೆ ನಾವು ಪ್ರೆಷರ್ ಹಾಕಬೇಕು, ಟೆಂಪ್ರೇಚರ್ ಕಡಿಮೆ ಮಾಡಬೇಕು. ಬಟ್ ಇನ್ ಕೇಸ್ ಆಫ್ ಎ ನೈಟ್ರೋಜನ್, in case of a carbon dioxide, or in case of methane and all that, suppose we apply small amount of pressure, ನಾವು ಸ್ವಲ್ಪ ಒತ್ತಡ ಹಾಕಿದ್ರು ಆರ್ಡಿನರಿ ಕಂಡೀಷನ್ ಅಲ್ಲಿ ಲಿಕ್ವಿಫೈ ಆಗುತ್ತೆ. ಸೊ ಟೆಂಪ್ರೇಚರ್ ಮತ್ತೆ ಕಡಿಮೆ ಮಾಡಬೇಕಂತಿಲ್ಲ. ಅದರ್ವೈಸ್ ವಿ ಡಿಕ್ರೀಸ್ ದ ಟೆಂಪ್ರೇಚರ್. ಟೆಂಪ್ರೇಚರ್ನ ಕಡಿಮೆ ಮಾಡಿದರೆ ವಾಟ್ ಎವರ್ ದ ಗ್ಯಾಸಸ್ ಆರ್ ದೇರ್, that gas get converted into liquid. Liquid means gas undergo compression, compress agide. So fuse shows negative deviation, meaning easily undergo compression. Okay, so that thing is measured using the value of Z. Is it Z is more than 1 or is Z less than 1 and all that. Okay, suppose we float a graph for only one gas. In case of a nitrogen, okay, suppose we float a graph of nitrogen gas, okay, you can consider pressure or volume along x-axis and compressibility factor along y-axis, Z versus pressure or Z versus volume for nitrogen gas or carbon dioxide gas, anything. Okay, I am consider a nitrogen gas here. For different temperature, what happens? It is constant temperature, correct? This is for constant temperature and different gases. This graph is for different gases and constant temperature. It is only one gas. I am changing the temperature now. What is the thing? Confuse ಮಾಡ್ಕೋಬೇಡಿ. ಈ ಗ್ರಾಫ್ ಅಲ್ಲಿ ಏನಿದೆ? Different gases ಇದೆ, real gases. Correct? ಯಾವ್ಯಾವಿದೆ? ಹೈಡ್ರೋಜನ್, ಹೀಲಿಯಂ, ಮೀಥೇನ್, ನೈಟ್ರೋಜನ್, ಕಾರ್ಬನ್ ಡೈಆಕ್ಸೈಡ್, ಆಕ್ಸಿಜನ್ ಅಂಡ್ ಆಲ್ ದಟ್. ಡಿಫ್ರೆಂಟ್ ಗ್ಯಾಸಸ್ ಇದೆ. ಇದು ಕಾನ್ಸ್ಟಂಟ್ ಟೆಂಪರೇಚರ್ ಇದೆ. ಈಗ ಟೆಂಪರೇಚರ್ ಅನ್ನ ವೇರಿಯೇಷನ್ ಮಾಡ್ತೇನೆ, ಒಂದೇ ಗ್ಯಾಸ್ ಅನ್ನ ಕನ್ಸಿಡರ್ ಮಾಡಿ. ಓಕೆ, ಅಂಡ್ ಕನ್ಸಿಡರ್ ನೈಟ್ರೋಜನ್ ಗ್ಯಾಸ್. ವಾಟ್ ಟೈಪ್ ಆಫ್ ಡಿವಿಯೇಷನ್ ಇಸ್ ಅಬ್ಸರ್ವ್ಡ್? ಫಾರ್ ರಿಯಲ್ ಗ್ಯಾಸ್ PV is equal to constant. Sorry, for ideal gas PV is equal to constant. For real gas I am consider nitrogen. The real gas is nitrogen, and I am plot a graph for nitrogen by considering the different temperature. Okay, so nitrogen in ಮೇಲಿನ ಗ್ರಾಫ್ ಅಲ್ಲಿ ಏನು ತೋರಿಸಿದೆ? Nitrogen shows negative deviation, easily undergo compression. So there is no difficulty during the compression of the nitrogen gas. That means it shows negative deviation. At higher temperature, we need more pressure. ಏನಾಗ್ತಿದೆ? At high temperature, ಜಾಸ್ತಿ ಟೆಂಪರೇಚರ್ ನಲ್ಲಿ ಇದ್ದಾಗ, okay, at high temperature we need more amount of pressure. Why? Molecules goes far apart each other, so ದೂರ ಹೋಗಿರ್ತದೆ, ಲಿಕ್ವಿಡ್ ಆಗೋದಿಲ್ಲ ಬೇಗ, ಪ್ರೆಷರ್ ಅನ್ನು ಜಾಸ್ತಿ ಹಾಕಬೇಕು ಅಲ್ವಾ. ಸೊ at the higher temperature condition, gaseous molecule goes far apart each other. Because of that we need more amount of pressure. So at that condition less deviation, negative deviation ಏನಿರ್ತದೆ ಆವಾಗ ಕಡಿಮೆ. ಯಾಕೆ? So not easily undergo compression. When we decrease the temperature, less deviation is observed, more negative deviation is observed. So T1 is greater than T2, greater than T3. Okay, so what it indicates? When temperature decreases, the temperature decreases from T1 to T3, the deviation is more. That means easily undergo compression, easily undergo easily liquefy. So in this case we observe the different points, the points at which this gas behaves like a ideal. For this temperature in this case, so in these cases the nitrogen gas behaves like ideal. Why? This real gas crosses the ideal gas curve at that temperature. So this temperature is named as Boyle's temperature. What's the name of the temperature? Boyle's temperature or point. Boyle's point. Okay. Boyle's temperature or Boyle's point. What's the definition now? The definition of Boyle's temperature is temperature at which real gas behaves like a ideal. Okay, very easy. ಏನಾಗ್ತಾ ಇದೆ ಇಲ್ಲಿ ಈ ಟೆಂಪರೇಚರ್ ಅಲ್ಲಿ ಏನು ರಿಯಲ್ ಗ್ಯಾಸ್ ಯಾವ ತರ ಮಾಡ್ತಾ ಇದೆ ಐಡಿಯಲ್ ಗ್ಯಾಸ್ ತರ ಬಿಹೇವ್ ಮಾಡ್ತಾ ಇದೆ temperature at which real gas behaves like a ideal is known as Boyle's temperature or Boyle's point. Very important. Okay, one mark again question. Okay, Boyle's point or temperature means temperature at which real gas behaves like a ideal. Okay, now at what condition real gas behaves like ideal? At very high temperature. Suppose temperature is higher, then pressure is required more, correct? Or in ordinary condition any gas behaves like ideal at very high temperature and very low pressure. Okay, please remember, at very high temperature, low pressure, the gas behaves like a ideal. Okay, so this is about the compressibility factor and the behavior of real gas with the ideal gas. Okay, what are the important things under this video? Compressibility factor. Okay, what is the definition of compressibility factor, what is the mathematical form, and what is the value of Z for real gas and ideal gas, what is the compressibility in nature, and what is Boyle's temperature. Okay, in the next class we will discuss about van der Waals equation. Okay, thank you for watching.